All right, 4.6. Let's do 4.6. In this section, we learned that our shooting percentage is equal to our shots made divided by attempts. And actually, I'm going to change it. I just don't like the way that looks. I'm going to change it to success. I don't know. Let's just say shots made. I don't want you guys to get confused. Over attempts. Okay, so a player in a basketball game made 18 shots, has a 72% shooting percentage. Which equation determines the number of attempts? So remember, we cannot put a percentage into a formula. So, and nothing really here has a 72 in it, so they're not trying to trick you with that. But I just want you guys to remember that, that we can never ever put like a percentage into our formula. Oh my gosh, so wobbly. Okay, so we take the decimal and we move it twice to the left, all right, 0.72. And so that means that the percentage, that 0.72, has to equal shots made, which is 18, divided by attempts. And we don't know attempts, so it's going to be divided by x, all right? That one. Now we're going to write an equation that represents each situation. Okay. It doesn't say solve it. That's what I'm staring at right now, trying to figure out if I need to actually solve this equation or not. A player made 34 shots in a basketball game with an 85% shooting percentage. How many attempts did they get? Okay, so a 0.85 has to equal shots made divided by attempts. So just this is 0.85. It's the percentage. Remember this formula, shots made goes on top. Attempts is unknown. When it's unknown, when they say how many, that's x. Boom. And again, they didn't say solve, so I'm inclined to leave it like this. A player made 26 shots in a basketball game out of 60 attempts. How many shots in a row do they need to make for a 60% shooting percentage? Oh, let's look at that. So they want a 60% shooting percentage. Currently, they are not at that. If you divide 26 by 60, you'll get some number, 40-something%, not 60%, okay? But if we take the 26 and the 60, we can't erase it. That's our current percentage. If we take some more shots, though, how many more shots? I don't know how many more shots. So x more shots. If I take x more shots, that's going to increase. If I take and make x more shots, that's going to increase my shots made by x, so plus x. But it's also going to increase my attempts, so it's also going to be plus x. All right, so this is the situation where you do plus x and plus x. And I'm not going to solve because, again, I don't think they want me to. Okay, in a basketball game, a player made 12 shots out of 30 attempts. How many shots in a row do they need to make to reach a 50% shooting percentage? All right, so right now, they are shy of that 50% by 3 shots. If they had made 3 of these existing shots more, they would be there, 15 out of 30. They're not, so let's go see. I want a 50% shooting percentage. I have made 12 out of 30 so far. I'm gonna take more shots, hope to make them all. So it's gonna improve my shots made and my attempts by this unknown number. And I'm gonna see how many x needs to be for my percentage to raise to 50, okay? First thing we do, you guys, we get x out of the denominator. And the way we get x out of the denominator is to multiply both sides by whatever that denominator is. Nope, it's 30 plus x. I don't know what I was thinking there. Okay. And then now, over here, this cancels with this, All right, and then over here, you have to please remember to distribute. And then we get 15, 0.5 times 30 is 15, plus 0.5x equals 12 plus x, okay? And now, I subtract. Okay, I want to be super clear. So now you guys, the problem is I have an x here and I have an x there, and I want to isolate x. That's how I solve for x. So the first thing I want is I just want one x to be trying to isolate. I'm going to subtract that 0.5x over to this one. And then what this all becomes is 15. I didn't do anything to the 15. It's still there. The 0.5x and the minus 0.5x cancel. Next I have the equal sign. Next I have the 12 that I didn't do anything to. And here, x minus 0.5x, just remember that's a 1x. So what you're really doing is 1 minus 0.5, which is 0.5x. Okay, now I got x out of the denominator. I combine my x's. Now I have a two-step equation to solve. The first thing I'm just trying to isolate that x. So I'm gonna move the 12. And I get 3 equals 0.5x. And now this 0.5, don't subtract it because it's just 0.5 right next to an x. No operation given. That means it's multiplication. So you solve by dividing. Divide both sides by 0.5. And then this cancels, and you get x equals 3 divided by 0.5 is 6. That's how many shots you gotta make to raise your percentage, all right, in a row. You gotta make 6 shots in a row to make up for the 3 shots that you missed that kept you. Anyway, I hope that made sense, but if not, forget it. Just remember this. Okay, a player made 72 shots out of 120 attempts. Write and solve an equation to determine how many shots in a row they need to make for an 85% shooting percentage. Here we go. We need that 0.85 to equal the 72 over the 120, but more shots are being taken, so they're gonna get added to the top and the bottom, and now we solve, just like here. Step 1, get x out of the denominator by multiplying whatever that denominator is. Okay, and now we're going to, on the right side, cancel that out. So go ahead and do that. Sorry, I was grabbing a calculator. Alrighty. Now, on the right side, they cancel. Boop, boop. And on the left side, I must distribute. And 120 times 0.85. Oh, that one I could have done. Actually, no, I couldn't have. It's 119.15. And then 0.85 times x is 0.85x. And it will equal the 72 plus x that's left on that side. And then now I got the situation where I have an x here and an x here, and I just want to combine them. So I'm going to subtract 0.85x from both sides. I'm going to continue this up here. 119.15 is still there. 0.85x minus 0.85x cancels. The equal sign, so that plus sign I just wrote, don't need it. The equal sign is next. 72. And now this is 1 minus 0.85, which is 0.15. Okay. Now just isolate that x, so move the 72. And that's 47.15. It's probably a good idea to have a calculator handy now, guys. And then now the 0.15 with an x right after it, no operation given means divide. Cancels, cancels, x equals, ooh. I got 314.3. So what I would do with this, man, that sucks. That's a lot. But it makes sense. I mean, 85 is a high percentage, and right here, they're like not that close. Unless I made a mistake somewhere, but I don't see a mistake. Okay, it is what it is. All right, so what I would say, you guys, how many more shots do they need to make? I know that 0.3 would normally round down, but I would argue they haven't reached the 75% until they do more than 314 shots. So I might say 315 shots. But I am an overthinker. I would probably accept 314 as well. Okay? With just a few games left in the season, is it likely for the players to reach this 85% shooting percentage? Oh yeah, okay, here we go. Now we gotta understand basketball at least a little bit. I would say in a few games, a player, one single player, to make 315 shots, unless they're like Wilt Chamberlain, or I mean, Kobe had a lot of games, I remember. I don't know. I think most of our average players scoring 20, 30 shots. I don't think it's happening, guys. Especially since they're going to miss some too. They're not going to make them all. No. I gave my explanation verbally. Alrighty. Okay. Now we're going to solve for x. Alright, you guys. We got this. We got this. It's the same goals, the same steps. Number one, get x out of that denominator. How? By multiplying whatever that denominator is by both sides. So times 3x to both sides. My 3x's cancel. 3x times 5, 15x equals x minus 7. Okay, so this looks a little different than the way the others looked. But step 2 is still, if I have two x's on two sides of the equation, try to combine them with each other. So I'm going to move this x over here, subtract it over. The reason, you guys, I'm doing the opposite is whenever we travel across the equal sign, we got to do the opposite of what's there. So this cancels, and now I have 14x. 15x minus 1x is 14x equals negative 7. Divide both sides by negative 7. Oh, wait, what? Whew. I don't know what I was thinking there, you guys. I'm so sorry. Don't divide both sides by negative 7. I broke my own rule. My rule is to keep your eye on the prize. Keep track at all times of what you are doing, or else you're just going to go around in circles aimlessly. What I'm trying to do is isolate x. That 7 is not a problem. The 14 is. I want to divide that 14 on both sides. And now this cancels, and I get that x equals negative 7 over 14. That's negative 1/2. Your calculator may have told you negative 0.5. I'm okay with that as well. Okay. Over here. Same thing. Step number 1, let's get x out of the denominator by multiplying whatever that denominator is to both sides. But that means I got to distribute that 11. Cancel. 11x plus 99 equals 8x. Now I got this x situation again. I got two x's on both sides. You guys, it's my personal preference. I recommend it for you to not move the only thing that's on one side of an equation. The reason is, it's not technically wrong to do, but the reason is you guys get weird when that happens, all right? You just, I don't know, you get weird. You do weird stuff, your math stops mathing, okay? So even though we usually like moving the smaller number over to the bigger number to avoid a negative number, I don't recommend it in this case. Again, not wrong. If you can do that and execute it and get the right answer, cool. But I recommend, since the 8x is all alone here, let's move the 11 instead. The 11x's cancel. We get 99 equals, and 8 minus 11 is -3. And now again, I got a number and an x, no plus sign, no minus sign in the middle of them. This is not +3 to both sides. This is divide 3. And x equals, this is going to be negative, and it is going to be -33. Okay, you guys see how fun? How fun is this? It's so fun. Oh, thank goodness. This one I thought was going to be bad, but it's not going to be that bad. Here we go. Get x out of that denominator. Multiply both sides by x. Cancel on the right. Distribute on the left. I get x squared minus 4x equals x minus 6. Okay, here we go. Now, at this stage in the game, on the other problems, we were like, oh, there's multiple x's, let's combine them. Let's be really aware of our situation here. We can combine that and that, okay? However, a viat is a quadrat, that one's squared, not a like term with these guys, okay? So the best I can do is combine my yellows. I'm still gonna have the green and whatever these combine to. In this situation, it is not going to be possible to isolate x. Okay, that's not true. You can if you complete the square. But just, you know, for the purposes of what we're actually going to do, we're not going to isolate x here. We are going to move the x over to get the x squared minus 5x equals -6. And then I hope at this point, this rings the alarm of, oh, whenever I have ax squared plus bx plus c, I want it to equal 0, and then I'm going to solve it by either factoring or quadratic formula. Or completing the square, which is technically isolating x. But I don't know why nobody does that. On a problem where my b is an odd number, I would never do that, okay? I'm going to try to factor. 6 and 5 look promising. Just remember this. You cannot factor unless it equals 0. So step 1, add the 6 to both sides. And now we have x squared minus 5x plus 6. And remember, I told you guys, if you're not going to learn all 4 different ways of factoring, at least learn this one because it comes up most often. Here it is. Okay, you're looking for 2 numbers that can multiply to make 6 and also add to make -5. So off to the side, what can multiply to make 6 and add to make -5? I can only multiply to get 6 with 1 and 6 and 2 and 3. And actually, you guys, both of these have the potential to make 5, right? Like 2 plus 3 is 5, 6 minus 1 is 5. So we pick one, we try it. If it works, great. And if it doesn't, we try the other one, okay? I'm gonna try to choose the wrong one first so you see what happens when it doesn't work, okay? So I'm gonna start with 1 and 6. Great, 1 times 6 is 6, okay. But it needs to be -5 when we add. So, well, that can only happen if the 6 is negative. -6 plus 1 is -5. But now, -6 times 1 isn't +6, it's -6. So I can keep messing with it. I'll either get this or this. I'll never be able to get both with 1 and 6. So that's my clue that 1 and 6 doesn't work. And then I might panic a little for a second and go, ah, crap, I gotta use the quadratic formula. But then I'm gonna go, no, wait a minute. This is one of those rare cases where there's a second possible option. Let's try 2 and 3. The 3 I know has to be negative like the 5 because it's the bigger number I wrote down, and that always matches the bottom number. And now in order for them to multiply to make a positive 6, the 2's also gonna have to be negative. And the negative 2 and negative 3 do add to be negative 5. So this works. These are my guys. So I'm gonna take this right over here, and I'm gonna go boop, 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 and make my 2 sets of parentheses. And this is gonna be x minus 2, x minus 3. Okay? And now, I need to see what makes this equal 0. So 2 will make it 0. You can set x minus 2 equals 0 and solve, or maybe you can just tell by looking at it. Add the 2, add the 2, add the 3, add the 3. So x equals 2, x equals 3. And that's it. Okay, here comes the question before the spiral review. Let's see what they got in store for us. Ayan has made 4 shots out of 16 attempts. His goal is a 76% percentage. That's not good. That's not good. 4 out of 16. He's only at 25% right now. After a lot of practice, he thinks he can make 80% of the rest of his attempts. How many attempts does he need to get to 76? Holy crap. What a good question. Also, Ayan is going to be shooting a lot of basketballs. Let's try it, okay? So he wants a 76% shooting percentage. So we want 0.76 to be our shots made divided by attempts. Our shots made currently are 4, and our attempts currently are 16. But now Ayan is gonna shoot, he's gonna shoot some hoops, okay? He's gonna shoot a lot of baskets. So his number of attempts is going to increase by how many, because that's what they're asking. How many attempts does he need to make? Well, I don't know how many, so x. So his number of attempts will increase by x. And in the past, we were looking at how many shots we have to make in a row, meaning no shots missed, meaning also added x to the top, because that was all of x was shots made before. But now, Ayan is very realistic. He knows he's gonna have to take a lot of shots. He knows he's not gonna make them all, but he thinks he can make 80% of them. So here, our next amount of attempts is x, remember that, right? We let x be our attempts, new attempts. In math, the word of means multiply. 80% of his next attempts is 0.8x. You multiply it. He's only gonna make 80% of these attempts. So on the top, I'm not gonna add x, I'm gonna add 0.8x. That's how many shots he will make, okay? So for example, if he took 10 shots, he would make 8. We would be adding 8 to the top and 10 to the bottom, okay? Now we solve this the same way we've been solving everything. We multiply both sides by 16 plus x, because that's the denominator and I need it out of there. And then now I get 0.76 times 16, which is not what I got. 12.16 plus 0.76x, and that must equal this 4 plus 0.8x. And I'm like running into this now. I don't like that. Here, let me highlight the equation I'm working on right here. It ends right there. And then now I got some x over here and I got an x over there, and I want to combine them. So I'm going to move the 0.76 over. and I get 12.16 equals 4 plus 0.8 minus 0.76 is 0.04. So use your calculator. If you're iffy with decimals and stuff, you guys don't make a silly mistake here. And then now I solve this two-step equation first by subtracting the 4 to get 8.16 equals 0.04x. And now I have to divide both sides by 0.04. 204. Ayan has to make 204 attempts. Make 80% of them to raise his crappy start from a 25% to a 76%. It's not easy to raise a percentage. Okay, now we're gonna calculate some slopes. Okay, you guys, slope is rise over run, as we remember. That means I wanna see my change in y over my change in x. Okay, so conceptually we could look at this and go, oh, my y didn't change, so my change in y is 0, and my change in x is 9, because I went from +8 to -1. That's a 9 difference, and so this is 0. So you could see how with reasonable numbers, just understanding slope, you could find it fairly easily. However, we also learned in Algebra 1 this equation, that slope is y2 minus y1 over x2 minus x1. And we were told to label our points x1, y1, x2, y2, so we don't make a mistake, and then go bring everybody here. y2 is -9 minus y1 is -9. You guys, they're both negative. It is what it is. Don't go changing it because it looks funny. Divided by -1 minus 8. All right. Over here, my negative does become a positive. And so this is -9 plus 9, which is 0. And on the bottom, it's -1 minus 8, which is -9. And 0 divided by -9 is a big fat 0. Our slope is 0. Do not say there is no slope. Don't say that. There is a slope. It's 0, okay? A slope of 0 means I've got myself a horizontal line. It has a slope. How steep is it? It's 0. It's 0 steep. So it definitely has a slope. Keep that in mind. And now let's look at number 12. Number 12, we can use the formula. We can use the change in y, change in x business, all right? But let's just, I don't know, let's do one of them. If I did y2 minus y1, I get -7 minus 7 divided by 12 minus 12. And now I get -14 divided by 0. Okay, here's what we're not gonna say. We are not gonna say that this is 0. It is not 0. Okay, this is undefined. We are not allowed to divide by 0. Okay, that is kind of a big thing we've been focusing on in this unit. So here is where we say there is no slope. Okay, or you can say the slope is undefined. All right, and conceptually, you guys, this situation, if you plot these points, you will see that 12, 7 and 12, -7 form a vertical line. And the way I think of it is, slope is the measure of how steep a line is. A horizontal line is not steep at all, 0. If the slope is 1, I can give it a number. That's a slope of 1. That's a slope of 2. That's a slope of 3, right? But that line is as steep gets. It's just so steep. So how steep is it? Give me a number. 100? But that, like 200? 8,000? A million? Infinity? You cannot give me a number to measure the steepness of this line. So that's why we say it doesn't have a slope and it's undefined, okay? All right, that's it. Good luck.